Okay, so it's question 4 on the paper. Jenny and Omar are each allowed 2 attempts at a high jump. I just thought I will mention at this point that I was the middle school high jump champion when I was younger. You don't need to applaud, it's alright. The probability that Jenny will succeed on her first attempt is 0.6. If she fails on her first attempt, the probability she will succeed on her second is 0.7. Calculate the probability that Jenny will succeed. Well, yeah, we can probably just go straight into working this out, but if you do feel that you need a tree diagram for thinking this through, then you could draw a tree diagram for it. If she succeeds, well, this is her first attempt, isn't it? Probably she will succeed on her first attempt is 0.6. So the probability she fails on her first attempt is 0.4. We'll call that succeed and fail. If she fails on her first attempt, the probability she will succeed on her second attempt is 0.7. So the probability she fails is 0.3. And we are asked for the probability that Jenny will succeed. And there's 2 ways that we could do this, isn't there? We could say that is, well, if we look at the end of these branches, see, she succeeded there. That branch has a probability of 0.6. She succeeds if we follow this route through it, which is 0.4 times 0.7, which would be 0.28. On the other hand, this branch here, 0.4 times 0.3, that's the probability of her failing. So we've got all of the options laid out before us. The probability that she succeeds is 0.6 plus 0.28, so 0.88. Can we see that the other way we could have thought about this is the probability of her succeeding is 1 minus the probability of her failing? So we could have equally done 1 minus 0.12, because if she doesn't succeed then she fails, which also gives us 0.88. So either way that we approach it, we come to that same answer. It's quite nice to see that there are different ways that we can attack these things. Okay, part 2 says the probability that Omar will succeed in his first attempt is P. If he fails in his first attempt, the probability that he will succeed on his second attempt is also P. The probability that he succeeds is 0.51. Actually, having worked this through for Jenny, we can kind of think it's the same situation, isn't it, really, that he's got. It's just we haven't got numbers on this. We're just dealing with the probability. So if we wanted to, we could draw an equivalent little diagram to show what happens. What was it? That. And we're told this time the probability he succeeds on his first attempt is P. And we know that probabilities add up to 1, so if he doesn't succeed, he must have failed, and so that must be 1 minus P. And then it's the same probability that he succeeds again, so again, the same probability that he fails, 1 minus P. And we've got the same 2 approaches that we can take. We're told the overall probability that he succeeds is 0.51. So we can think of this either way, can't we? That's either P plus 1 minus P times P is equal to 0.51. So we can calculate it that way. Or, if we've got an alternative route to do this, we could say that 1 minus P times 1 minus P is 1 minus 0.51. And either way that we do this, we'll be able to work through for an answer. I actually think this one seems a little bit to be a slightly simpler way of thinking about it. But if we do it this way, because we started this way, what have we got? P, plus P minus P squared is 0.51. So we get 0 equals P squared minus 2P plus 0.51. and we're there with a quadratic equation which we need to solve, and we've got a calculator so we can do that with the quadratic formula. I'm going to have to do it, aren't I? So we get P is minus B plus or minus the square root of B squared minus 4AC all over 2A. And nobody's working this out for me. So fine, I'll do it with this horrendous calculator that's been left here. Is it yours? Has anybody lost a particularly unpleasant Aurora AX595 PK? No, okay. Nobody will own up to it. Bear with me, I'm nearly there. It gives us 17 over 10 if we do the plus root. That's an interesting answer, isn't it? That's 1.7. Or, if we do the negative bit, then that gives us 3/10. This is a probability. So 1.7 is of course nonsense. It can't be 1.7. P is 0.7 is a much nicer answer. Can you see if you've gone this route, there's quite a nice thing that works out here. This is 1 minus P squared is 0.49. If we now square root this, why have I written 0.7 now? Sorry. Great, is that better? I looked at 1.7 and 0.3 and ignored them both. If we square root 0.49, we get 0.7. And if 1 minus P is 0.7, then P is 0.3. We actually get plus or minus 0.7, don't we? So that the minus one gives us the 1.7, but we're going to ignore all of that bit, and that's the answer that we want. So that was quite a neat way of doing it. There you go. But you can see the tree diagram was by no means essential, but sometimes it just helps you organise your thoughts to draw a little tree diagram, and there's nothing wrong with doing that. And if they haven't given you enough space in the answer booklet to do it, then put your hand up and get some more paper and draw as big a tree diagram as you like on extra sheets of paper. And that's maths.